You know, if you get a bunch of developers in a room and ask them what clean code actually means, you're going to get a dozen different answers. A lot of people will tell you, it's just personal style, it's a preference. But what if it's not? What if we could get past the opinions and look at actual data to see if these principles really, truly matter? Well, let's do just that. Oh yeah, we have all been here. You open up some file, you stare at it for a minute, and this is literally the only metric that makes any sense. It's hilarious, right? But that feeling, that gut punch of confusion and frustration when you're looking at bad code, that's universal. And it points to a problem that is very, very real and very expensive. And that problem, well, it's got a name. We can call it the curse of bad code. And believe me, it is so much more than just a little headache. It has serious, long-term consequences. Okay, just let this quote sink in for a second. This isn't just about a project slowing down or being a pain to work on. Robert C. Martin, Uncle Bob, tells the story about a real company, a company with a popular product that literally went out of business. And you know what the killer was? Their own code base. The mess got so bad that adding new features became impossible, development just ground to a halt, and the company completely failed. This metaphor of waiting is just perfect. It totally captures that feeling, doesn't it? You're trying to move forward, to get something done, but you're just being dragged down by the swamp of bad code. Every single step is a struggle. You're fighting the code instead of building with it. And your productivity, it just plummets. So, if bad code is this curse that can actually kill a company, what's the antidote? What's the cure? Well, it's not some fancy new tool or the latest framework. It's a change in how we think. It's all about adopting a craftsman's mindset. This is such a powerful and, frankly, challenging idea. What it's saying is that at the end of the day, the responsibility for code quality rests with us, the developers. Think of it like this. Would you want your surgeon to skip washing their hands just because a hospital administrator told them to hurry up? Of course not. The surgeon understands the risks. And the argument here is that it is just as unprofessional for us to give in to pressure when we know it will create a mess. Okay, so what does this professional standard actually look like? Well, let's hear from some of the absolute giants of our field. Here's Bjarne Stroustrup, the guy who created C++. He talks about elegance and efficiency. And notice that last part. Clean code does one thing well. Keep that phrase in your head because it's going to be really important in a minute. Building on that, we have Grady Booch, who adds another layer here, readability. The idea that code should read like well-written prose is wow. It means the code shouldn't be a puzzle. Its purpose, its intent, should be crystal clear, not buried under layers of cleverness and complexity. And finally, here's Ward Cunningham, the inventor of the wiki, and he gives us this wonderfully practical definition. Clean code isn't surprising. There are no nasty shocks waiting for you. It's predictable. You read it, and it does what you think it's going to do. And that makes it so much easier to work with. Okay, so elegance, readability, predictability, these all sound great, but are they just feelings? Or can we actually nail this down to a concrete principle, something we can actually measure and test? You bet we can, and that brings us to the idea of a single responsibility. The single responsibility principle, or SRP for short, is really one of the cornerstones of this whole clean code philosophy. And the idea is beautiful in its simplicity. A piece of code, whether it's a class or a function, should do one thing and only one thing. And why is that so important? Because if it only has one job, it only has one reason to ever change. And that just crushes complexity. And this diagram just illustrates it perfectly. So look over on the left. You've got this one class, C1, that's just trying to do way too much. It's a jumble of different jobs and responsibilities. It's a mess. But now look to the right. See what happened? It's been refactored, split into C1A and C1B. Each one now has a single, focused job. They're simpler, they're cleaner, and they're way easier to understand. So that's the theory. Looks great on a slide, right? But the big question is, does this actually work in the real world? If we go around applying the single responsibility principle, does our code actually get better? Well, this is where we get to stop guessing and start looking at the data. So a group of researchers did this awesome case study. They went into two huge, real-world industrial software systems. We're not talking about little toy projects here. And they looked at 131 different times that the code was changed specifically to follow the single responsibility principle. And they measured the impact on a really key metric of code quality called modularity. And the results were absolutely staggering. I mean, look at these numbers. At the method and class level, applying SRP boosted modularity by over 128%. That's not a typo. And even when you zoom out to the big picture architecture level, you're still seeing a massive 42% improvement. These are not small tweaks. This is a huge, dramatic improvement in code quality. So, case closed, right? SRP is amazing, applied everywhere, all the time. Well, not so fast. Because a big average improvement is one thing, but what about the risk? Is it always a good idea? This is where the story gets really, really interesting. So check this out. When they applied the principle down in the weeds to individual methods, yeah, it was helpful most of the time, 82%. But, and this is a big but, in almost 1 out of every 5 cases, it actually made things worse. So at this very low level, you're taking a bit of a gamble. Now, compare that to what happens when you zoom out to the architecture level. When you apply the exact same principle to the bigger components of the system, the change was beneficial or, at worst, neutral 100% of the time. Let me say that again. There were 0 cases where it was harmful. That is an incredibly powerful finding. The higher up you go, the safer and more reliable this principle becomes. So, what on earth do we do with this information? Well, this brings us right to the heart of what it means to be a professional developer. It's not just knowing the rules, it's knowing when and where to apply them. This is the professional's dilemma. So, does this mean we should just go around splitting up every class and function we see? Well, the data pretty clearly suggests it's not quite that simple. Context matters a lot. And here is the key takeaway from all of this. Down at the low level of methods and classes, there's a trade-off. Sometimes, when you try to make a class more focused, that's called improving its cohesion, you might accidentally make it more tangled up with other classes. That's increasing its coupling. But at the higher architecture level, it's a clear win-win. Applying the principle there tends to improve both cohesion and coupling at the same time, making the whole system cleaner and healthier. So is clean code just a preference? The data says a clear no. Principles like SRP have a real, measurable, and positive impact. The art, the craft, for us as professionals, is knowing how to apply them wisely. And really, it all comes back to this simple, beautiful idea known as the Boy Scout rule. Every time you touch a piece of code, just try to leave it a little bit better than you found it. It's not about achieving perfection overnight. It's about a continuous professional commitment to making things better one small step at a time.